So welcome everyone to the In the Field webinar. This webinar series is brought to you by the Growing Point, Alberta Wheat and Barley Commission's Agronomy Extension Platform. My name is Jeremy Boychyn and I am the Commission's Agronomy Extension Specialist, and I will be the facilitator for today. Luckily, you won't have to see my face the whole time, but I'll help manage all the questions going back and forth between everyone and Charles. So yes, I have Dr. Charles Geddes here with us from AAFC Lethbridge. So thank you for joining us, Charles. But before we get started, I'm going to give a quick intro and a few housekeeping items as we move forward. So the Alberta Wheat and Barley Commissions typically have a hands-on approach to agronomy and extension, but with challenges in terms of COVID and the amount of people that can meet in one place and the challenges around field tours, we thought this was a good way to connect researchers with agronomists and farmers. So these webinars are focused on just that. So we're bringing in industry experts to talk about specific topics to help you better manage challenges on farm. So with every webinar, there's a few different ways to interact. There's going to be a Q&A button. So everyone who's on right now, if you go to the bottom of your webinar screen, you'll see a chat button. If you don't see that chat button, click the More button and open up, and you'll find the chat button in there. In there, once you click that, you'll be able to type to the panelists and to everyone else. And you can use that to ask questions. Where you type in that little chat box, there's a little drop-down menu just above there. And right now it says All Panelists. Click that and change it to All Panelists and Attendees. This allows all the attendees to see your questions as well as the panelists. So sometimes conversations start and more questions can build when all attendees can see your question. There's also the Q&A button. That Q&A button will get, when you click that, you can type a question that'll get directed to me, and then I'll be able to address that either with Charles or to you personally, and then get Charles to address it later. And then the third way is to raise your hand. So in the participants or in the chat section, if you raise your hand, I can then open up your microphone and you can ask Charles a question directly. So those are your three different options. Again, I would recommend going to that chat now and changing it to all panelists and attendees so everyone can see your comments. I would highly recommend anyone who wants to share this on Twitter, use the hashtag The Growing Point and tag Alberta Wheat and Alberta Barley as we move forward. We love seeing your tweets. But that is all of the housekeeping things. So I will pass it on to Charles for now. And you will get to see all his information regarding resistance management. So thank you, Charles.
All right. Yeah, thank you very much, Jeremy. And thanks everyone for joining as well. This is the webinars are sort of a new platform for us researchers. So so you might have to bear with us, or bear with me, I guess, while we make our way through this, and hopefully it goes well. Yeah, my name's Charles Geddes. I'm a research scientist. I work with Agriculture and Agri-Food Canada, based out of Lethbridge, Alberta. And I work in weed ecology and cropping systems. And more specifically, in the last few years, my research program has sort of shifted a little bit into focusing on herbicide resistance, looking at monitoring of herbicide resistance, so surveying as well as identifying novel herbicide-resistant weed biotypes, and then from there going into developing integrated weed management strategies or programs to help manage those biotypes across the Canadian prairies. So again, yeah, thanks for joining. So today we'll be covering three main points and related to field scouting for herbicide resistance. More specifically focusing on scouting after post-emergence herbicide application. Whereas later on in the season, later in August, we'll have another webinar focusing on pre-harvest scouting as well. So today I'll be talking about, first of all, knowing your enemy, because it's very important to know what to look for when you're out in the field as well. And then we'll go through some scouting tips and talk about what to do if you suspect that you have resistance on your farm. So before we jump right into it, Jeremy, I think, has a poll that he's going to bring up here, hopefully.
It's up. People can vote on it now.
Okay, great. So yeah, if you are a farmer, do you have herbicide-resistant weeds on your farm? And this won't be traced back to you, so feel free to answer truthfully. So first of all, talking about knowing your enemy. So a large part of the presentation will focus on background of herbicide-resistant weed biotypes with a focus on Alberta. I always like to start off with some definitions, because if you're going to sleep during the webinar, then this is the time to do it. But in all seriousness, one of the biggest, I think, discrepancies when we're talking about herbicide resistance comes back to the definition of resistance. Because I think that many people actually define herbicide resistance specifically in different ways. So these definitions are pulled off of the Weed Science Society of America website. So these are sort of the standard definitions that we use in the field of weed science. And I wanted to focus on the difference between resistance and tolerance, first of all. So herbicide resistance is the inherited ability of a plant to survive and reproduce following exposure to a dose of herbicide normally lethal to the wild type. And the main point there is underlined, it's an inherited trait. When we look at herbicide tolerance, however, it's an inherent ability of a species to survive so a species to survive and reproduce after herbicide treatment. So in general, this implies that there was no selection or genetic manipulation, and that the plants are naturally tolerant. So an example of this would be say wild buckwheat, treating wild buckwheat with a lower rate of glyphosate, so among the lower field rates. And often we'll see lack of control of plants like wild buckwheat, but in general that's due to the fact that that species has a certain level of natural tolerance to the herbicide, compared with something like, say, treating kochia with glyphosate. So kochia, we know, is herbicide resistant, and in general that species was originally susceptible. However, plants have been selected for resistance after repeated applications. So the difference is that selection pressure causing the resistance. So here we have the results of the poll showing 53% of farmers say that they have herbicide resistance on their farm. And we'll get to that in a second here. Okay, another thing that I wanted to bring up quickly about selection pressure is that some of the different herbicide groups, they have a different amount of selection pressure, you could say, for herbicide resistance. And this is due to several factors, including the efficacy of the herbicide, how they work on the plants, and also how conserved or variable the target site is among plants as well. So what I wanted to bring up here is group 1 and 2 herbicides at the very top. So they have higher selection pressure specifically for target site type resistance. And this is why those two groups are included in our tier 1 surveying when we look at herbicide resistant weed surveys. The other thing I wanted to point out is that near the bottom here, we have group 4, so synthetic auxins, 6, so photosystem 2 inhibitors, examples, say bromoxynil. Then group 9 is glyphosate, and group 10 is glufosinate. And you'll notice that they all have lower selection pressure for target site resistance. However, we do know that in some species or in one species in particular, we have stacked resistance now in Western Canada to the synthetic auxins and glyphosate as well. Okay, so poll number 2, Jeremy. And I'll just continue on here while he's bringing that up. So, okay. Now, in follow-up to the last question, does your neighbor have herbicide-resistant weeds on their farm? So this map here shows the global cases of herbicide resistance. So by country, looking at the number of unique herbicide-resistant weed biotypes. And essentially what we mean by unique herbicide-resistant weed biotypes is that is a herbicide species a weed species by a herbicide mode of action. Exactly, an interesting social experiment here. So 82% of people say that their neighbors have herbicide resistance. Curiously similar to what I thought. And we'll get into both of those here in a couple slides. What I wanted to point out with this slide here was that Canada currently, we're in 3rd place as far as number of herbicide resistant weed biotypes. In 1st place, we have the United States, followed by Australia with the mid sort of 90s for number of unique cases. And then Canada, currently we're sitting at about 75. Yeah, so this figure is showing the discovery of unique cases of herbicide resistance over time in Canada. And you can see that it's increasing essentially in a linear fashion. And currently we're sitting at about 75, beginning in the mid 70s. And this is what it looks like for a number of unique cases distributed across Canada. Focusing in on the prairies here, so Alberta, Saskatchewan, and Manitoba, we're sitting in sort of the low to mid 20s as far as unique cases within each prairie province. Alberta somewhat ahead of the other prairie provinces. Okay, so poll number 3 there, Jeremy.
Launched.
All right. So what percentage of annual cropped fields are infested with herbicide-resistant weeds? So this figure here is showing the discovery of unique herbicide-resistant weed biotypes in Alberta over time. So starting in 1988 with common chickweed, followed closely by kochia, both resistant to the ALS inhibitors or group 2 herbicides. Shortly thereafter, we have sort of an era of grass weed resistance, or the discovery of grass weed resistance, so in wild oat and green foxtail. And then followed by almost, we'll say, a decade and a half of looking at new resistant biotypes, specifically mostly to group 2 herbicides, broadleaf weeds resistant to group 2 herbicides, up until recently, where we had glyphosate resistance discovered in kochia, initially discovered actually in 2011, and then the subsequent survey here shown in 2012. Okay. So most people on the webinar here are saying that 33% of annual cropped fields, that 60% of annual cropped fields are infested with a herbicide-resistant weed, which is actually very close, essentially right on. And of course, that is when we're talking about these different types of herbicide resistance, it's an issue because we're working with a limited number of herbicide modes of action. Here we're showing the release of new herbicide modes of action over time. And initially it looks like there's quite a few. And however, some of these have been either discontinued or are not used for our purposes here in Western Canada. And the point that I wanted to make here is that essentially the timeline stopped about 3 decades ago. And there really has not been a new mode of action released in the last 3 decades up until just recently. where there was a mode of action released for production systems that are outside of what we would use here in Western Canada, in addition to another one, which is essentially just the initial discovery of a mode of action of a herbicide that we had already. So one of the projects that I'm leading currently is the prairie herbicide resistant weed surveys. Here, these figures are showing the last round of surveys from 2014 to 2017. And these surveys cover 800 fields across the Canadian prairies over the course of about 4 years. So currently, so right now we're showing the third round of the surveys, but right now we're working on the fourth round, which started in 2019. And so what we do in these surveys is we, first of all, have permission from all of the growers to go out and sample in their fields. And the idea when we get out there is we would walk an inverted W pattern in any, or essentially right before harvest. And any wheat patches that we can see from walking that W pattern, we go over and collect viable seed from those weed patches and then bring that seed back, dry it down, and test it for resistance back at the research center. And these surveys are useful because they come up with statistics on herbicide resistance. And because we've maintained the same methods over time, we can look at a timeline of resistance in the Canadian prairies. So that poll number 3 showing that about 60% of fields were infested with herbicide resistant weeds. And essentially that's right on. Here we have a graph showing the percentage of fields, or the estimated percentage of fields based on this survey that contain a herbicide resistant weed biotype. And in Alberta, we're sitting at about 59% of those fields, just above Saskatchewan and still a decent amount below Manitoba. So I guess that, so everyone was sort of right on with the estimate of 60% there, as well as pretty close with the poll number 1. So 50% of farmers suspect that they have a herbicide resistant weed on their farm. So other useful statistics that we can derive from these surveys are the area of infestation of herbicide-resistant weeds on the prairies. So currently estimated at about 23.7 million acres across the prairies. And the important part about this survey is that it's paired with a grower management questionnaire, and with responses, so farmer reported responses to questions, we can actually estimate the cost of herbicide resistance for Western Canada. So covering these 3 prairie provinces, currently estimated at about $528 million annually. So I like to pull this figure up whenever I'm submitting grant applications, because it gives a pretty clear justification for investment in research in herbicide-resistant weed management. So I'll go through some of the results from those, from the most recent round of surveys, and specifically bringing up maps from Alberta. So Alberta was last sampled in 2017. So starting off with one of the most abundant herbicide-resistant weed biotypes that we have in Alberta and across the prairies is Group 1 resistant wild oat. So Group 1 or ACCase inhibitors being in-crop graminicides, so herbicides that farmers would use to manage grassy weeds like wild oat in grassy crops like your cereal crops. And you can see the increase over time here, increase in Group 1 herbicide-resistant weed biotypes. And when we're looking at the percent here, so this is the percentage of fields where wild oat was sampled during that survey. So across the prairies, I think there was about 570 some fields where wild oat was actually collected, and we're looking at the percentage of those fields. So in Alberta, we're sitting at about 58% of those fields have Group 1 resistance in wild oat, and looking at the map here, covering essentially from the very south all the way up into the Peace region. And this can be an issue for growers when we're looking at herbicide options here. So these options are coming directly from the 2019 Guide to Crop Protection, or the Blue Book. So that if there's any deviation, that's on them, it's not me. So essentially what I did here was pulled out all of the herbicide options for managing wild oat in various crops. So in wheat, in barley, canola, pea, and lentil. And essentially, if we're assuming that we have group 1 resistance, and that group 1 resistance confers resistance to all of the chemical families within the group 1 mode of action, that means that we're losing activity of these herbicide modes of action. So anything that is red and crossed out means a loss of efficacy. Anything that is just red but not crossed out is loss of efficacy of one mode of action that would have activity on wild oat. So now looking at group 2 resistant wild oats, we can see, looking at the graph here, we see a large increase since the last survey was conducted. And the reasoning for that is because essentially the increasing abundance of group 1 resistance across the prairies in wild oat, and once growers realizing that they had a group 1 resistant wild oat biotype, they often, the first thing they do is switch to a group 2 herbicide for wild oat management. So you can see there's a little bit of a delay in the increase in ALS inhibitor resistance in wild oat for that reason. But currently sitting at 40% of the fields where wild oat was collected in Alberta, and again, sort of ranging across agricultural production or annual crop production in Alberta. So back to our herbicide chart here. So looking at specifically at group 2 modes of action. So again, assuming that we would have blanket resistance to all group 2s in wild oat, we would be losing these herbicides. And then of course, where the real problem comes in is once you lose both of those tools, and looking at wild oats with resistance to group 1 and 2 herbicides. And again, we see more of an increase since the last survey, currently in about 29% of the fields that we have in Alberta. And of course, this can create issues when we come to our herbicide chart. Assuming that we have blanket resistance to all herbicides in group 1 and 2, we're losing a large number of our options here. So to boil that down, these were the remaining options in that chart. And what I want to point out, so assuming group 1 and 2 resistance, we have the options in wheat, barley, canola, pea, and lentil. But if you look a bit more closely, each of these have have PRE after them, meaning that they are registered for pre-emergence or pre-plant window of application rather than an in-crop application. So in fact, the only crop here where we would have an in-crop application registered for control of wild oat is in our herbicide-resistant canola varieties, either Liberty Link or Roundup Ready. So this is showing, first of all, the importance of a crop rotation, right? And including canola as one of those components of the crop rotation, because it will help delay the development of group 1 and 2 resistance in wild oats. So if that wasn't bad enough, we also have group 8 resistance in wild oat to a soil applied herbicide, pre-plant herbicide in trilate. And the last survey for trilate resistance in Alberta was conducted in 2007. So unfortunately, the samples from the third round of surveys were not screened for trilate resistance. And at that time, about 15% of the fields where wild oat was sampled showed resistance to trilate. And so Alberta was in the lead out of the 3 prairie provinces in that case. So I think there's a need to revisit this survey as well here in the near future to look at whether trilate resistance has increased over time, staying the same, or maybe even decreased. So of course that would we would lose efficacy with group 8 resistance in Avidex and partial efficacy in Fortress as well. So bringing us to essentially the only options for control of wild oat, mainly being glyphosate or Liberty as well in canola. But it's also important, so in all of the crops other than canola, glyphosate is registered as a pre-plant or pre-emergence herbicide and essentially has no residual activity, meaning that you will get control of your wild oat at the time of planting, but not afterwards. So one of the big gaps that needs to be addressed in weed science, especially in Western Canada here, is looking at some of these other pre-plant herbicides. You'll see all of the herbicides labeled as suppression now. And if there is a way that we can increase the control that we're receiving from some of those pre-plant residual herbicides to help with wild oat management once we're dealing with resistance, multiple resistance in wild oat. Okay, so now I'm going to go through a series of different weeds. I'll probably go through them quite quickly, but this is essentially just to give you an idea of what to look out for when you're scouting for resistance. So here we're showing group 1 resistance in green foxtail in Alberta sitting at about 21%, as well as group 2 resistance in green foxtail at about 6%. And it's important to note that in the last survey in Alberta, we actually didn't find group 1 and 2 resistance, multiple resistance in wild oat. So it's either not present currently or just not present at the level in which we can pick it up in this survey. And looking at some of the broadleaf weeds now, we have group 2 resistance in chickweed. Here looking at Alberta. And when interpreting these trends over time, it's important to also look at the maps at the same time to look at how many samples were actually collected during the survey of that particular weed species. Because obviously a lower number of samples being tested can show up as some weird looking trends over time compared with something like wild oat where we have many samples collected across the province. Cleavers is a big one. So more isolated to kind of the central Alberta area, not as present in southern Alberta, but resistance showing up in the last survey at 44% of fields where cleavers was tested. So this is looking at group 2 resistance, and as I'll touch on later on, we also have group 4 resistance in cleavers. One of the recent ones, so this is kind of a big discovery, and the first time that ALS inhibitor resistant lambsquarters has been found in the prairies. There was one case found in the last survey that showed resistance to group 2s. So that, based on the number of samples collected, that equated to about 3% of the fields. So this is one to definitely look out for when you're scouting for resistance. Here's narrow-leaved hawksbeard at 29%, just on this recent last survey in 2017. Shepherd's purse, also showing up in the last survey across the prairie provinces. Smartweed at 62%, again, looking at the trends and the number of samples actually collected, there was a low number of samples collected, so I would use a grain of salt when interpreting the actual percentages here. Spiny annual sow thistle, we again see this interesting trend where it appears to be decreasing, but I believe that that is also due to the number of samples that were collected. However, it does appear to be better. So our control of spiny annual sow thistle does appear to be better than the resistant cases that were popping up in the second round. And stinkweed here, group 2 resistance and stinkweed, more isolated to kind of the southern or south central part of the province. And it's also important to note that there's several weed species here that did not show up in the maps, were not picked up on in the last round of surveys, and that's due for a few reasons. First of all, looking at, here we have the species, the type of resistance, and the year in which that biotype was initially found in Alberta. So group 3 resistant green foxtail has been around for for a while now, but it doesn't show up on the surveys because group 3s are not included in the tier 1 herbicides that we currently test those populations with. So that's why we don't have the map for group 3 resistance in green foxtail, similar to group 4 or synthetic auxin resistance in cleavers and also hemp nettle. And that's why those biotypes are not showing up in the survey. But also important to note is the group 2 resistance in a few other weed species that we have here in Alberta, but still not showing up on those surveys. And the main reason for that, I think, is because those biotypes are currently not at the level of abundance of some of the others that would be showing up in the survey. As I mentioned, so across the prairies, we're looking at sampling 800 fields over 4 years, but also focusing specifically on Alberta, that equates to 250 fields in 2017 that we looked at. So it could be that these biotypes just aren't abundant enough to show up in that survey. It could also be because those biotypes did not have viable seed at the time of sampling. So after that round of looking at the surveys here, we have another poll question.
It's up.
All right. Okay, so scouting fields. So when scouting fields 3 weeks after post-emergence herbicide application, what signs are indicative of herbicide resistance? So take some time to read through those and choose which one you think is the best answer. So continuing on here with Russian thistle. So the other kochia and Russian thistle are two that don't show up in the general herbicide resistant weed surveys that we conduct. And that's mainly because the seed on these plants actually are not viable at the time of conducting those surveys pre-harvest. So Russian thistle and kochia are currently sampled in a different survey that is post-harvest, usually late September, early October. So the 2017 survey for Russian thistle showed group 2 resistance in Russian thistle at 62%. And Russian thistle is also on our watch list as far as glyphosate resistance, because we know that there's glyphosate resistance in Russian thistle just south of the border in Montana. And then, so to one of my favorite weeds, if you know my research program at all, we focus quite a bit on kochia here in southern Alberta. And essentially the story was, so group 2 resistance in kochia was initially found in the late 80s. And over the course of about 2 decades, that type of resistance spread to the point where we consider all kochia populations in Western Canada now resistant to ALS inhibitors. Then in 2011, the first cases of glyphosate resistance were found just south of Lethbridge in Warner County here. And the subsequent survey in 2012 identified out of about 300 populations, you can see shown on the map here, about 5% of those populations were resistant or showed resistance to glyphosate, mainly in 3 counties. So Vulcan, or looking around Vulcan here, around Taber and around Warner as well. Okay, so the poll shows live plants beside dead plants of the same species. And that makes me very happy to see that, as we'll see in a few slides here. That is one of the main identifying characteristics of herbicide-resistant weeds when you're scouting in the field. So the subsequent survey, kochia survey in Alberta, was conducted 5 years after this baseline survey. And after 5 years, the incidence of glyphosate resistance in kochia increased from 5% to 50% of the populations. So it's spreading very rapidly. You can see shown by the red and blue dots here red and green dots on this map. And in addition to glyphosate resistance, so Hugh Becky, who is leading the survey, they also found dicamba resistance or synthetic auxin resistance for the first time in kochia in Alberta, shown by the blue dots. So dicamba resistance at the time showed about 18% of the populations were dicamba resistant, and 10% of the populations are actually triple resistant, so to group 2s or ALS inhibitors, glyphosate, and dicamba. So we have triple resistant kochia in about 10% of those populations. And the next survey for Alberta, so these surveys go province by province. So we are planning on coming back to Alberta in 2020. So this is in collaboration with researchers from Ag Canada in Saskatoon as well. And I say maybe there because we're still waiting to see how things work out as far as the COVID-19 situation and whether we'll be able to survey fields in 2020. But currently the plan is for a fall 2020 survey of kochia. So some of the last background here. So Alberta, this is looking at the status of kochia resistance. So what we've done in our program is taking some of those, or well, actually all of the samples from the 2017 Alberta survey, the Alberta kochia survey, and testing them a bit further. So one of the questions that we wanted to answer was around this new type of synthetic auxin resistance that was found in Alberta. And there was several questions from growers asking whether these populations are cross-resistant to multiple synthetic auxins, fluroxypyr being a big one that we use here on the Canadian prairies, especially for kochia management. So we've done some more testing on those populations. So out of the 300 populations that still had viable seed, these are the results that showed up here. So obviously the overlapping of the circles is showing resistance to multiple herbicides. So it's important to note that glyphosate is its own mode of action, whereas dicamba and fluroxypyr are different chemical classes, but both considered synthetic auxins or group 4 herbicides. So what our recent screening showed actually was quite interesting. And you can see, looking at the overlap between dicamba and fluroxypyr, there's only 4% of those 300 populations that actually overlapped, showing resistance to both dicamba and fluroxypyr. But if you look at each herbicide individually, so outside of that overlapping area, we have here adding up to 15% of the dicamba, or of the populations resistant to dicamba but not fluroxypyr. And then here, 9% of the population is resistant to fluroxypyr, but not dicamba. So what this indicates is that I suspect these are actually separate modes of action that are conferring resistance to each of those biotype, or to each of those herbicides. But also it shows that in that survey, we underestimated the synthetic auxin resistance that we have here in Alberta. And rather than being in 18% of the populations, it's actually in more like 28%, so a bit higher than we had initially expected. But this is also good news because it indicates that you can still achieve control with a different herbicide that's still available for kochia management if you have auxinic resistant kochia. In the future for these surveys, here we're looking at the plan going forward. So again, I mentioned Alberta kochia survey was in 2020, and the herbicide resistant weed survey, where we cover multiple weed species, is planned for 2022 in Alberta. And these dates might change a little bit, depending on whether we're able to go out and survey fields this year. So moving into the scouting side of things, so there's a bit less content on scouting, because I think that the message on scouting is fairly straightforward, and feel free to ask any questions if you need clarification on this. But what I wanted to show here first is some results from the grower management questionnaire that was sent out for the last round of the Alberta herbicide resistant weed survey. So out of the 250 fields, we had about a 40% or so response rate on the questionnaire. And this is looking at herbicide resistant weed management, right? So the percentage of respondents that use each of these tools for weed management in general, shown in the red here, or for management of a herbicide-resistant weed when they know that they have one on their farm. And what I wanted to point out that scouting after your herbicide treatment is one of the, it's among some of these other tools that many growers use to manage herbicide-resistant weeds. And of course, it's important for weed management in general, but also herbicide-resistant weed management. So, on to some scouting tips. Okay, so here we have looking at conditions that are conducive to either herbicide activity or potential herbicide failure. So these lists on the screen here, first of all, looking at good activity from your herbicide. So essentially what the conditions that we're looking for are conditions that are largely favorable for active crop growth, or active weed growth, sorry. So here looking at favorable soil moisture, good fertility, moderate temperatures, high relative humidity, young growing weeds, an important one, healthy and competitive crop stand, and also clean water. But then looking over at the opposite here, so conditions that are conducive to herbicide failure, we have things like misapplication, whether it's an inappropriate dose or the wrong equipment or the wrong nozzles, for example, used for that specific herbicide. Inappropriate weed staging is a big one. So it's important to pay attention to the weed stages that are on the herbicide label or in the Blue Book, the Guide to Crop Protection, because often we see applications outside of that window, and and obviously that generally leads to a lack of control of the weed. So it's quite often that we'll receive calls about suspected herbicide resistance, which just end up being due to the fact that the herbicide was applied outside of the recommended staging. Because once weeds get to a certain stage in growth and development, many herbicides become much less effective. Some other problems, so carrier problems, looking at hard or dirty water with lots of particulate matter, rainfall shortly after application, and another big one is the environment in which you're applying the herbicides or shortly thereafter. I often think about herbicides as sort of the Goldilocks of weed management. I mean, that they're very effective, but they don't like it if it's too hot or too cold or too wet or too dry. They just need that just right environment in order to see full activity from your herbicide. So this is another big one to consider when you're looking at your field scouting after your herbicide application. And really, I have at the end of the list herbicide resistance, which is, I put it there specifically at the end of the list because it's only after you've ruled out all of these other potential options for herbicide failure where you can consider that the population might be herbicide resistant. And even at that point, the population, it can be suspected resistant, but it's not confirmed resistant until it's sent for resistance testing and confirmed properly. Okay, so here moving on, potential signs of herbicide resistance. So getting back to that poll question. So these are all potential signs of herbicide resistance in the field and things to look out for when you're scouting your fields. So previously controlled weeds that are now escapes, given that all of those other factors are not a problem. In addition, looking at only one weed species that escapes in a field where all of the other herbicide or all of the other species on the herbicide label are controlled, especially given for the rate range that you're using in that herbicide. Also, irregular weed patches or patches that are growing over time. And one of the most important ones is if you have live plants next to dead plants that are of the same weed species. And I'll show that in a second here. And finally, field records show repeated use of the same products or the same herbicide mode of action over time. And this is where your field records are very important in diagnosing herbicide resistance. So poll number 5, Jeremy.
It's up and going.
All right. Okay, so what would you do if you suspect that you have a herbicide-resistant weed in one of your fields? Okay, so looking at, so when you're diagnosing or looking for weed control or scouting your fields for weed control or resistance issues, there's 2 scales that you need to look at. So first of all, looking at the field scale, but then also looking at the plant scale. So looking at these boxes here, so each box will consider a field, okay? And these are different symptoms that you might see at the field scale, contributing to lack of control or potentially even crop injury in some cases as well. And this is where some new technology like using drones for scouting fields can be quite important and actually quite a valuable tool when it comes to scouting weeds for weed control or herbicide resistance. So looking at these factors at a field scale, right? So just a general straight line is usually indicative of a plugged nozzle or potentially also a miss or overlap. I mean, maybe if I was driving, it would look like that. I think with GPS now, it would probably missing or overlap would show up more as similar to a plugged nozzle, you would think. Then also looking at small kind of roundish weed patches at either end of the field could be indicative of herbicide misses while turning. Also here looking at more on the crop injury side, probably looking at injury going into the first pass in a field, which eventually dies out, which could be due to some residual herbicide in the tank or improper cleaning or mixing of that herbicide as well. Then looking at drift, where you just see a gradual pattern into the field, likely drift from a neighboring field. So here we're getting into soil residue, where this would most often be seen in a certain area of the field, like say a low-lying area or on top of a hill. So an area that has different microclimate characteristics compared to the rest of the field. And you're seeing either crop injury or a lack of control in that specific area. And that can be, it could possibly be resistance because some of those areas can be essentially breeding grounds for herbicide resistance, especially when it comes to weeds like kochia that are fairly highly outcrossing. But also it could be due to herbicide residues in the soil because those different microclimate characteristics in the soil could potentially result in greater persistence of a herbicide or even more rapid decay of that herbicide as well, depending on the herbicide and the environmental characteristics. Then here's a different one that I sort of threw in here, which is maybe it's more of a newer concept based on some more recent research, but these blue dots here, representative of water or sloughs in your field, and the idea of spraying around those sloughs, you may be seeing somewhat of a halo effect around those sloughs. Okay, great. All right. Good answers again. One person would be crying. But sending sample for resistance testing, that's great. And that's what we'll talk about here in a second. So getting back to this pattern in the field where you see this sort of halo effect, it could potentially be due to consistent underdosing in those areas, where on the outside of your spray boom, you would be underdosing, and on the inside, you could be overdosing, depending on the spray technology that you're using. And consistent underdosing around those water bodies can actually lead, could lead to lack of control just in general, because they're not receiving the proper rate of the herbicide, but it can also lead to the development of resistance as well. More specifically, a different type of resistance, like polygenic resistance or metabolism-based resistance. So something that is related to an increase in or differential activity in multiple genes that confer that herbicide resistance. And metabolism-based resistance is sort of a classic example, where that area that's being underdosed, you'll basically be selecting for plants that would be normally controlled at the field rate, but slowly selecting over time for plants that are surviving lower rates of that herbicide. And the idea being that those plants would likely have a greater metabolism, and those plants would be crossing with each other, or maybe selfing plants as well. And the idea is that you're slowly selecting for higher and higher metabolism in those plants over time, and eventually that can result in polygenic herbicide resistance. So now at the plant scale here, so these are two examples of what to look for at the plant scale. As we mentioned, and was shown in that poll there as well. So one of the main symptoms of herbicide resistance is when you have a plant that's completely controlled beside a plant that's uncontrolled of that same species. So here in the bottom right of my screen, this is looking at a Russian thistle plant, and you can see quite obviously the skeleton of a Russian thistle right beside it. So this is a sign that this Russian thistle plant may be herbicide resistant. In addition, just looking in these plots here, so this is an experiment that we have looking at glyphosate resistance in kochia. So the crop here is lentil actually, and we would have sprayed solo, so a group 2 herbicide. But what we're looking for here, just even within the same plot, you can see kochia plants that are controlled, here shown by the chlorosis or necrosis that you're seeing. But then also in the interrows, you can see kochia plants that are a nice dark green color, indicating that they're quite possibly herbicide resistant. And obviously in this case, we consider all kochia populations group 2 resistant. That doesn't mean that necessarily all of the plants within that population are herbicide resistant, though. Okay, so field scouting tips. So to start off, keeping detailed records. So this is can be detailed herbicide records, first of all. So looking at which herbicides you're using in a particular field over several years. And the idea being helping with herbicide rotation or herbicide mixing, but also keeping detailed records when you're out scouting in the field. So is there a suspicious patch in a certain area? If you noticed a certain patch, say last year, and it's still there this year, that could be sort of an area to focus on when you're scouting for potential herbicide resistance. But also noting how large the patch is and whether it's increasing over time. So being consistent from year to year, so using sort of the same surveying methodology. Usually what I would do is walk this inverted W pattern in the field, but also try and focus on, so look at the field in general, but also try and check in areas that have, say, a different topography as well, because those areas may react differently to the same herbicide. So I have Scout Weekly here. I mean, that ideally we would be scouting weekly, looking for weed control and herbicide resistance probably about 14 to 21 days after the post-emergence herbicide application. So at a point where you would be able to see control from that herbicide, but also plants that are not controlled. And then scouting weekly thereafter. I mean, again, that's ideal. But there's sort of two periods where it's the most important, I think. In addition to obviously scouting or before you apply the herbicide to determine which herbicides you need to apply. So those other two areas are, again, starting about 14 to 21 days after post-emergence herbicide application for a few weeks there in a row. And then also pre-harvest. And the pre-harvest scouting comes in when we're looking at actually getting those populations tested for herbicide resistance. So in addition, understand the symptomology of the herbicide mode of action that you used in the field. So what are you looking for, and how long does it take to actually see those symptoms? With a herbicide like glyphosate, for example, complete symptoms may not show up for 3 weeks. Then looking at, again, patterns at the field scale, but also at the plant scale, and using the art of deduction. So as I mentioned, there's several different factors that can lead to a loss of control for when you use a herbicide. And it's only when you actually rule out many of the environmental and application factors that you can actually suspect that those populations are herbicide resistant. So on to the third part, which is, this is the shortest part of the presentation here. So what to do if you suspect resistance. So again, apparently some people would cry, but this is what I would recommend. So looking at, first of all, if you suspect that you have a herbicide resistant weed population, get a second opinion. When we're looking at the list of potential causes for loss of control, everyone looks at it a little differently. So it's important to get an unbiased second opinion on that population as well. Whether that's from, say, a local agronomist or a neighbor, or calling a researcher like myself. So the second point I have there, if it's caught early, consider other chemical control options. So the idea being that you still might be in the window where you could control that weed with a different mode of action. If caught later, then consider non-chemical control, or trying to use ways that you can decrease the viability of that seed going into next year. Because really, the whole point at this stage, if you suspect that you have herbicide resistance, is to try and eliminate viable seed production from that population. So that could look like coming in and mowing the population. If say you only have small areas of the field or small patches that you suspect are resistant. So coming in and mowing those areas, or say clipping if the weed seeds are above the crop canopy, depending on the crop and the weed species. So send a sample for in-season genetic testing. So I wanted to talk about this a little bit. So currently there's relatively few options available for in-season genetic testing for resistance. One of the best examples I think that we have right now is glyphosate resistance in kochia. And I'll get into that when I talk about, I think in the next slide, when I talk about diagnostic labs. So in-season genetic testing, so we're at a point here with technological development where we can actually test for resistance rather rapidly if we know the mechanism of action or the mechanism of that resistance. There's several factors that contribute to the how well a genetic test works. So again, I mentioned you have to know the mechanism of resistance, but also there's several biological factors about that weed that contribute to how well that type of resistance works. So for something like a diploid like kochia, the glyphosate resistance test it can be quite valuable, and you can actually get results, say, within a couple of days of submitting your sample, so guiding your herbicide choices. But also genetic testing, it doesn't work for all species. So one of the big questions that we have about wild oat, so there's multiple types of resistance in wild oat. So the question is, could we develop tests to cover all of those mechanisms of resistance? And would that be still an effective way for in-season genetic testing, for example? And finally, so leave a small patch to produce viable seed and try and make sure that the seed doesn't enter the seed bank. But collecting those viable seeds and submitting them to a diagnostic lab is your best bet at diagnosing whether you have resistance or not. And it can be a very valuable tool. So here I'm pulling up information on 3 different herbicide resistance diagnostic labs that we have here in Western Canada. This is not an exhaustive list of all of the labs. These are just ones that that I've been in contact with the most during my herbicide resistance research. So the Crop Protection Lab with the Saskatchewan Ministry of Agriculture based in Regina, they the type of testing that they currently offer is the grow it type of testing, where they would require viable seed samples. They would grow them out under a controlled environment and treat them with particular herbicides. So you can select for many different chemical families within the group 1s or the group 2s, for example. And so that's kind of it remains the standard as far as diagnosing resistance, because that type of diagnostic spans different mechanisms of resistance to the same chemicals. In addition, so AgQuest in Minto, Manitoba, focusing largely on the same biotypes as the Crop Protection Lab, just another option for a lab. And so if you go to the websites for any of these, they'll have information on the types of testing that they offer. Another important one, especially for kochia, is the Pest Surveillance Initiative based out of Winnipeg, Manitoba. And they are one of the labs that currently offer that in-season genetic testing for glyphosate resistance in kochia, which can be a very valuable tool. In general, the cost for testing a sample for resistance, so one sample for resistance to one mode of action or subgroup within that mode of action, is about $125 to $200, which, if you consider comparing that to potential herbicide failure in a subsequent year, that cost is very low, and it's an excellent investment that will help guide herbicide control decisions in subsequent years. Finally, I wanted to throw in a plug here. So for types of resistance on the prairies that are currently not known, or what we consider novel types of resistance, my lab with Agriculture and Agri-Food Canada in Lethbridge is offering free testing. So if a farmer or an agronomist suspects that they have a new type of resistance that has not really been documented in the province yet, they're welcome to email me. I have the forms to submit for that particular population, and we'll test for that type of resistance for free. And essentially, this is just a way to try and stay ahead of new herbicide-resistant weed biotypes and potentially catch them at a point before they become widespread. So I have several different examples of the type of resistance testing that we would offer. Last year, we offered glyphosate resistance testing in kochia, but we're transferring that test over to some of the other testing labs. Because we're at a point where glyphosate resistance in kochia is quite common now. But things to look out for, potentially PPO inhibitor resistance in kochia. So currently not documented in Western Canada or anywhere else for kochia, but it's one to be on the lookout for, because I see many growers shifting over to the use of these group 14 herbicides pre-plant for control of herbicide-resistant kochia. So things like AIM, heat, many authority. There's a long list of group 14 herbicides used pre-plant, and they're also on the watch list for a type of resistance to look out for. So for more information on herbicide resistance, here, looking at weedscience.org is essentially a worldwide database of herbicide-resistant weed biotypes, where some of this information presented today was collected from. And also, your guide to crop protection for your specific province has a list of herbicide-resistant weeds in Alberta as well that needs to be updated with a couple new biotypes. But if you suspect resistance outside of these lists, feel free to contact me and we can set up resistance testing, and also make sure that it remains confidential as well. So in conclusion, currently in Alberta, we have 26 unique types of herbicide resistance, and resistance across the prairies appears to be increasing based on our surveys. Scouting for resistance is very important, especially in early diagnosis of a herbicide-resistant weed biotype. And it's really important to test that weed for resistance as well, because this will help inform your herbicide management decisions down the road. And of course, we didn't cover it necessarily in this presentation, but prevention is always key to herbicide-resistant weed control, right? So trying to mitigate resistance in the first place. Reactive management is also possible, but it can be more expensive. So with that said, I'd like to thank everyone for listening, as well as thank all of my funders and collaborators, technical staff, and students, as well as thank the Alberta Wheat Commission and Jeremy for hosting me here today. So I'd be happy to answer any questions.
Thank you, Charles. That was very informative. We do have one question from Orest Fedorak. And I'd say this is kind of a big question, and I don't know if there's a specific answer for it, but maybe the answer would change depending where you are and who you're talking to. But are we providing enough awareness to farmers and retailers regarding resistance?
Yeah, so that's a really good question, and I think it's something that we could improve upon for sure, right? So right now we're trying to without outreach as much as possible and extension to make sure that this information is known. Some of the information included today are relatively recent discoveries, like the research that we're doing on fluroxypyr resistance that's not yet published, and things like that. So these are very recent discoveries that we've made. So those may not be extended to their full capacity at this point. But the idea is that we want to make awareness of herbicide resistance we want to cover as many avenues as possible. So that's both farmers and retailers and agronomists, right? Where we really need help is sort of spreading that information and how to spread it in a way that we know that it's accurate information as well, right? So there's a very limited number of weed scientists across Western Canada. So we need to rely on agronomists and other farmers to help spread that information as well.
Perfect. Harry Brook asks, any reports on resistance to aminocyclopyrachlor? Aminocyclopyrachlor, that's the one.
No, so not off the top of my head. So basically, what I've been presenting here today, it wasn't necessarily active ingredient specific. So oftentimes, when we're extending this information, we broaden it out to the group level. That being said, multiple active ingredients within those groups are tested to make sure that we can do that. With respect to that specific active, I don't have any cases to report that I know of.
Would that be an in-crop herbicide? Is that I'm not familiar with that one actually. It doesn't.
It's not a common one, so it's one that I would actually have to look up.
Okay, I'm glad I wasn't the only one. As soon as I said that, I'm like, should I know what that is? I'm not as familiar with that one. Do we know what group it is?
I could easily tell you if you gave me a sec.
Okay. While you're looking that up, I just want to thank you for taking the time. It's very informative. And for the sake of time, we'll pull an end to this. But keep in mind for everyone who's on, if you want to go back and watch this, this will be on YouTube, the full webinar, so you can go back and watch it again and find all that information. Just search In the Field either on YouTube or go to our website on the events page at Alberta Wheat or albertabarley.com. And again, join us on social media. And Charles will be doing a follow-up webinar to this in August, at the end of August. It would be August 26th. So if you go to our website now and find that link, you'll be able to register for that now. And that'll be things to address during harvest, how to collect samples, and how to make sure you're managing that resistance at harvest as well. Because as much as post-herbicide is important, harvest timing is important for resistance management tactics as well. So head over there and sign up for that now. And other than that, this is our actual last webinar until then. So thank you, Charles. And did you get a group?
Happy to be here. Whoever asked that question, I'll ask them to please send me an email and we'll follow up on that. So it's not a herbicide that's routinely included in our resistance testing, but it's definitely something that we can follow up on.
Okay. Brian Tiedemann said picloram or grazon. Industrial vegetation management product.
Yeah, so it's not typically one that we would be testing in our routine screening. But I mean, obviously, if there's suspected cases, it's something that we can look into.
Okay, well, thank you again, Charles. It's greatly appreciated, and I'm sure everyone found value from it. So we'll call her an end and let everyone go to lunch.
Thank you very much.